The power rule helps us understand what to do when we already have a number that has an exponent, but we also want to get add an exponent to the whole question. In that case, we multiply the exponents against each other and we leave the base the same. In other words, if we've got something like 4 to the power of 2, but now we have an exponent of 2 against the whole question, what we need to do is we need to multiply the exponents together. So this becomes 4 to the power of 2 times 2, which is the same thing as 4 to the power of 4, because 2 times 2 is 4, and that equals 256. So we got another question here. So what if we have 2 to the power of 3 and all of that to the power of 3? What do? Well, we're going to keep our base the same. So our base will be 2. But what we're going to do with the exponents is multiply them against each other. So that becomes 3 times 3, which means that then now we have 2 to the power of 9. And so 2 to the power of 9 is 512. And I've mentioned in other videos that when you use your calculator, you should have a little button that has an X and a little Y on top. It's a little button like this. And so this is what we use for exponents. So if we want to get 2 to the power of 9, what we do is we key 2, then you click your button that has an X to the power of Y, and then you're going to punch in your exponent. So 2 button 9, and you should get the 512. Okay, what when we're working with algebra? What if we had something like x to the power of 3 and all that to the power of 5? Well, nothing changes. Our base is still going to be x, and our exponents are going to be multiplied to each other. So 3 times 5. So this becomes x to the power of 15. Okay, here's another question. So we've got 2 plus 2 to the power of 2 and all that to the power of 3. So this is supposed to be a bit of a tricky question. So we've got everything to the power of 3, but the power rule only applies when we've got the two exponents. So that means that the power rule is only going to apply right here because both of these are exponents. So our next step will be 2 to the power of 3, because this has to go into the bracket. So this will be actually have an exponent of 3. So technically this is coming onto this one right here, and it becomes 2 to the power of 3. But when it comes to the other side, because this other 2 already has an exponent, then we have to follow the power rule. So the 2 stays the same, and we're going to multiply those two exponents. So notice that we're only doing it on that second number because it's the only number that already had an exponent. Okay, so this becomes an 8 plus, so this is the same thing as 2 to the power of 6, which means as we've got 8 plus 64, and when we add that together, we end up with 72. Okay, what if we had something like 3 to the power of 2 and all of that to the power of -3? Well, it doesn't change. We still have the power rule that we need to apply. So our base stays the same, and we're going to have our 2 times -3. So we know from integers that when we're multiplying two integers with different signs, so a positive and a negative, we always get a negative. So that becomes, the 3 stays the same because it's the base. 2 times 3 is 6, but because the 2 is the positive and the 3 is the negative, we end up with a negative. If you need a refresher on integers and multiplying integers, we do have a video already available for you to watch. Okay, so now we've got 3 to the power of -6, and there will be another video that will talk about negative exponents, but in this case this all goes over 1. So we've got 1 under 1, sorry. So we've got 1 And then we move this to the bottom to get rid of the negative sign. So this becomes 3 to the power of positive 6. So this is how we get rid of the negatives exponents. We have to put everything under 1. So we'll go 1 under, and then we keep the number 3 to the power of, this time, positive 6. So our answer would be 1 over 729. So notice the key here is that we're still following our power of power rules. Okay, and all of these, wherever there's an exponent, we're following our power of power rules. Okay, let's practice a few more questions. What if we have something like 4 to the power of 0 and all of that to the power of 5? Okay, so we can still apply our power of power rule. So we've got 4 is 0 times 5, which is the same thing as 4 to the power of 0. So what do we know about numbers that have an exponent of 0? So any number to the power of 0 is always going to equal to 1. It doesn't matter what it is. If we've got it to the exponent of 0 to the power of 0, our answer will always be 1. So for that one, we've got a 1. Okay, just wanted to look at another negative number like we did before. So what if I had 8 to the power of 2 and all of that to the power of negative 2? Okay, so we're going to apply the power of power rules. The base stays the same, and we've got a 2 times negative 2. So a negative times a positive equals a negative. So that means we have 8 to the power of negative 4. And so I said that when we have a number to the power of a negative, we have to put it all under 1. So we'll have 1, and now we bring down the 8 to the power of positive 4. So this is how we get rid of the negative sign. We put it under all under 1, and we keep now the number. So now we've got 1, and we got the 8 over 1 here to the power of positive 4, which is the same thing as 1. And then we've got, what's 8 to the power of 4? Well, if you do that on the calculator, you'll get 4096. So that would be our answer, 1 over 4096. Okay, what about if we have something like this? 3 times 4 to the power of 0 and all of that to the power of 5. Okay, so we've got here two exponents. And so we're going to bring this 5 right to the 3, right? So in reality, if you think about it, when a number does not have an exponent, it's the same thing as that number to the power of 1. For example, 4 to the power of 1 equals 4. 3 to the power of 1 equals 3. 19 to the power of 1 equals 19. So if you think about that, when we don't have an exponent, it's the same thing as saying 3 to the power of 1. So if we were to apply our power of power rule, it would be the same thing as saying 3 to the power of 1 times 4 to the power of 0, which is, we leave the base the same, 1 times 5, and all of that times 4, and 0 times 5. Okay, sorry, we have an exponent right here. Okay, so this becomes 3 to the power of 5, which is what I was saying. You could just put it right on top right here from the very beginning. And this becomes 4 to the power of 0, because 0 times 5 is 0. Okay, so what is 3 to the power of 5? 3 to the power of 5 is 243. And what did we say was 4 to the exponent of 0, or 4 to the power of 0? Any number to the power of 0 equals 1. So 243 times 1 is 243.